I know this is a quick shifting gears into another chapter, and you just got your brains fried on the last chapter. So now we'll call it over easy. You got the brains fried. We're going to do it over easy. I want to give enough to introduce chapter 11. This chapter 11 homework is due in a week, next Wednesday. So we will finish chapter 11 on Monday. We'll finish it. But I want to, and don't plow into this homework and say, I'm going to get it done by Monday. We're not going to talk about cis and trans. You're going to see some things here. It says draw cis-2-pentene. That makes a difference. The next one is trans something. We won't get to that today. We'll get to that on Monday. So do it in pencil. So that on Monday, if you see that, I didn't realize that, you may have to go back and make some changes. Or just, I ordinarily don't like you to try to do it and you'd end up doing it the first time the wrong way. But if you can kind of adjust gears and say, okay, now I realize that wasn't right, this needs to be changed. Chapter 10 was about saturated hydrocarbons. Organic compounds with carbon with single bonds around all the carbons. That's a saturated hydrocarbon. In chapter 11, we're going to start looking at unsaturated hydrocarbons. Alkenes with an E-N-E ending have double bonds. Have a double bond in them. It just has to have one double bond in it. It's an alkene. Alkynes, I didn't write that very well. Alkynes, and we're talking about the Y-N-E ending, have carbon-carbon triple, a carbon-carbon triple bond in it. Simplest alkene is not with one carbon. There needs to be two carbons. If you're going to have a carbon-carbon double bond, it has to be at least two carbons. So it starts with ethene, ethine. We'll get to aromatics at the end of the chapter. What do we mean by aromatics? So here's a simple little comparison. Eth, two carbons. The prefix still means the same thing in chapter 11. So hex still means 6 carbons. Pent, 5 carbons. Eth means 2 carbons. So there's ethane with single bonds around, all single bonds around those carbons. 4 single bonds around the carbon. Here's ethene. Now notice we're still going to have a total of 4 bonds. So this is going to count as 2 bonds. 1, 2, 3, 4. So because I got 2 bonds between those 2 carbons, that carbon and that carbon only needs 2 hydrogens, not 3. Ethine, 1, 2, 3, 4 bonds. This happens to be a carbon-carbon triple bond. There's your 4th bond. There's only 1 hydrogen on each of those carbons in ethine. Models would kind of look like this. We might, I don't know if we'll come back. We will come back probably and talk a little bit more about the geometry here. The ethane, it swivels around here. It's 3-dimensional. Ethene around this double bond is actually a planar situation. All of those atoms are in a plane. They're not stuck out anywhere. You could get a sheet of paper and all of those would be on the paper. There wouldn't be a hydrogen sticking up above it and below it. So that is a planar, it's least planar around the double bond. Triple bond is linear. 180 degree bond angle here. 180, 180. That's what we're talking about here. Bond angle of 180 degrees. Okay, now let's look at pentane. It's zigzagged and that's saturated. Pentene, it has some parts of the molecule that are saturated, but it does have a double bond, so it is an alkene. We don't say, oh, there's more. We don't look at how much is saturated, how much is unsaturated. If there is any unsaturation, it's going to behave like an alkene when it reacts. Does something like that. It has a double bond, and that double bond functions differently than a single bond, than a carbon-carbon single bond. That's why we call it a functional group. This is a functional group here. It changes the whole class of molecule now because that double bond functions differently. So that is an alkene, and it's pentene. We will, I'm going to mention the ynes, pentyne. We got a triple bond here. And there's 5 carbons, 1, 2, 3, 4, 5 carbons. So it is a pent. There's a triple bond, yne. Okay? Okay, now the other feature in here, it's real small there, but I'll write it bigger. We're going to start counting the carbons where the double bond begins. The double bond begins right there on that end, so that's going to be carbon number 1, 2, 3, 4, and 5. And when we name it, we're going to have an ene, so we need a number. Unless it's ethene, obviously ethene it's on the first and second carbon. There's only 2 carbons there. So there's no ambiguity. I don't need a number. You don't need to tell me, that double bond starts on the first carbon. It can't start anywhere else. But that'd be the same way with propene. I think that's the same way with propene. Yeah. But butene, butene can start on the first or second carbon. So we need a number to say, and that number is referring to the ene. And that ene is referring to a carbon-carbon double bond. With me?
Would you never have the double bond in the middle then? It'll always be on one side or the other?
No, that's a good question. Let's look at this molecule. Let's try it like this. There it is in the middle. Not in the middle, but along the way. Right? So what is that? 2, pentene. This is carbon number 1. This is carbon number 2. This is not going to be 3 pentene. You come over here, 1, 2, 3. No, I'm going to start at the end that gets me to the double bond the quickest. The shortest distance to the double bond. So this is a good example. This is 1, 2, this is 2 pentene. And now you can see why we had to call the other one 1 pentene. Because if you just gave me the pentene, I'd be scratching my head. I'd say, I wonder where the double bond is. I don't know where the double bond is. There are options for it. A couple different places it could be. So you need that number. Yeah, okay. And the other thing is when it is a pentene, when you're seeing a prefix or a suffix in a parent name that is referring to the functional group, this is what this thing is, then we're not going to worry about substituents. We're not going to worry about, this substituent is closer to that end and the double bond than the double bond is to an end. We're going to focus on the double bond and then number the substituents accordingly. The double bond will take precedent. We'll get some examples of that. Okay, so that's 1 pentene. one pentyne, and there could be a two pentyne. Two pentyne. I'm getting ahead of myself a little bit. Physical properties, I won't dwell on this real long. They're very similar to alkanes. These things are nonpolar. They're nonpolar. They are unsaturated, but they are nonpolar, just like alkanes are nonpolar, just carbon and hydrogen bonds, which means, would you expect them to be soluble in water? No, because water is polar. So these are also not soluble in water. Alkanes aren't soluble in water, alkenes aren't soluble in water. Would you expect them to be soluble in alkanes? Yes. Like dissolves like. So alkanes are soluble in alkenes, and alkenes are soluble in alkanes. Why? Because they're both nonpolar. Good, you're getting this. Same sort of thing about boiling point. The bigger the molecule gets, the higher the boiling point gets. I'm not going to dwell on that. I want to say enough that you can start at least relating to the homework assignment. You don't have to do much of it, but you should think about it over the weekend. You should scratch through chapter 11 a bit and start looking at various things. Ethane, ethene, ethyne, propane, propene, propine, and you see there's no numbers in there. Let's do this one. Let's do a CH3, CH2, CH2. Well, all I did was just wrote that the other way. There's only one place this double bond can be. It's got to start on carbon number 1. All right? This is carbon number 1, 2, 3. That's carbon number 1, 2, 3. So there's only one propene. There's not a 1 propene and a 2 propene. There is only a single propene. And we don't need the 1. I'm trying to say it without a 1. Likewise with propyne. There's no middle set of carbons where that triple bond can be. It's going to be on the end, and it doesn't matter if I write it this way. It's still on the end, and that end is going to be number 1. So I don't need the numbers there. But if you start getting up to butene, butine, and on, now you're going to start needing some numbers. Number from the end that will give you the first carbon of the multiple bond, that means double or triple, the lowest number. Prefix the name with the number of the first carbon in the multiple bond. So you can see it takes 2 carbons to make a double bond. We're not putting a number for each one of them. We're just putting a number for the first carbon in the double bond. 1 pentene. Where's the double bond? It's between carbon 1 and 2. But I don't need the 1 and the 2. I just need to tell me where does the double bond begin. And then I know that it has to be with the next carbon. Prefix, branch, and substituent names as for alkanes. Once you figure out where the double bond, which end of the molecule is closest to the beginning of that double bond, that dictates the numbers of those carbons, which then also dictates what the substituent numbers are going to be. Let's get a couple examples of that. All right, let's get an example. Let's take this top one. That's an alkene. What's the longest chain? Okay, IUPAC naming, always start with what is the longest chain? Seven? I hear 7. 7? Everybody's good with 7? All right, 7. I like that. And 7. So we're going to start, well, here's 7, right? 7. I think I'll just kind of go above it. I don't want to. So there's the longest chain. I don't want to interfere with this double bond right here. So which end of the molecule, now notice, this is a good example, because right over here, I go, wow, the methyl group is on the second carbon. But that would put the double bond beginning on the 1, 2, 3, the fourth carbon, right? This would be carbon number 4. If I said this was carbon number 1. But if I said this is carbon number 1, 2, where does that double bond begin? Carbon number 3. So that is carbon number 1. It takes precedence over that methyl group, or a chloro, or whatever it is over there. We're going to put ene on the parent name here. We're going to leave this out and this out in the parent name. So well, let's go ahead and get the parent name. So it's 7. So it's hept what? Heptene. All right. Now we got that ene. So what number has to go in front of heptene? 3. It's 3 heptene. And what else is it? 3 ethyl, 6 methyl, 3 heptene. Aren't we glad IUPAC didn't come up with a system of naming children? This is IUPAC naming children. No one's there. Everyone's going to have a nickname if this is the way we name children. Okay. 3 ethyl, 6 methyl, 3 heptene. So we made a couple of points here. The double bond reflects into the parent name. You have to say where the double bond begins. So once you want it to have the lowest number possible for the double bond, for where it begins. And then that dictates what end you're going to start counting from. 1, 2, 3, 4, 5, 6, 7. And then you number the substituents. You give the substituents numbers after you have that structure. Well, let's just do this one and then we're fine for today. Longest chain. Remember, rule number 1. Don't ever forget rule number 1. That's what this is all about. This was all about rule number 1. Don't forget it. Longest chain drives you towards the correct name of a compound. So how many carbons here? 6. So it's what? Hexyne, because it's an alkyne. Okay, now if I go here 1, 2, 3, if I started here 1, 2, 3, well, it doesn't matter where I start. But in this case, since I do have a substituent here, I want the lowest numbers for everything possible. So it's 3 hexyne no matter what end I start counting on, but it's going to be 2 bromo, 3 hexyne. This is the end I'm going to start on. All right? It still gets me to a 3 for the start of the triple bond, but it gets me a lower number for the substituents. Okay, so that's a start. If I said anything to you as you start out, let's see. You got 2 hexyne. Let me do 2 pentyne. Let me just show you something here. This is your very first problem. 1A, 2 pentyne. So I'm gonna put 5 carbons along here. 5 carbons. 2 pentyne. So that's telling me on the second carbon there's going to be a triple bond.
You said that's the first one.
Pardon me? The first one is 2-hexyne. I'm doing one similar to it. I'm not doing that one for you. Okay, but what I want to show you. Now let's finish this off. I'm going to put a hydrogen there, there, and there. What am I going to put here? Nothing. Why? 1, 2, 3, 4 bonds. What am I going to put on that carbon? Nothing. 1, 2, 3, 4 bonds on that carbon. How many hydrogens go on this one? 2. Okay? So don't just come out of chapter 10 where you put a hydrogen above and below every carbon and think that applies in chapter 11. Got me? Okay, doesn't apply. There it is. There's the structural formula of 2-pentyne. And when you get the double bonds, count them. 1, 2, and then what over there, and figure out how many hydrogens to put there. Do it in pencil. I would avoid anything that says a cis or a trans because I will just assume you don't understand that yet. You might, but you might want to assume you don't understand that yet.